Okay, good morning, afternoon, or evening, everybody. Welcome to the Discover Enhanced Wildfire System Capabilities with NASA's VIIRS Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started here. What I will do first is begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, what I'd like for you to do is enter those either in the Q&A panel rather than the chat, and you should, or you could enter that into the chat, and you'll find those located on the right side of your screen. If you do not see that, there are three small dots in the lower right corner of your screen, and if you click on those, you will be able to insert a check mark next to either the Q&A or the chat. Okay, today's webinar is being recorded. The recording will be posted both to the NASA Earth Data website as well as to our NASA Earth Data YouTube channel within a week of completion, but normally it takes me just a couple of days. Once completed, I will send an email to all registrants with the recording links and also a link to the presentation slide deck used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. Eastern. During today's webinar, we will have 3 speakers. Our first speaker is Diane Davies. Let me actually pull up the agenda here in a second as well. Okay, Diane is the operations manager for NASA's Fire Information for Resource Management System, or FIRMS, and also for the Land Atmosphere Near Real-Time Capability for EOS, or LANCE. She will kick off this afternoon's event by providing some context regarding NASA's FIRMS and an introduction to its capabilities. From there, we will transition to our second speaker this afternoon, Jenny Hewson. Jenny is the Implementation and Outreach Manager for NASA LANCE and also a FIRMS collaborator. She will continue our presentation with a live demonstration of the key features and functionalities for the expanded FIRMS interface. After she is finished, we will transition back over to Diane for a short demonstration, and then we will move to our final speaker for this afternoon, Otmar Olshina, who is the lead applications developer for NASA's Level 1 and Atmosphere Archive and Distribution System, Distributed Active Archive Center, or LADS-DAC, and he's also the primary developer for the expanded FIRMS interface. Otmar will provide a demonstration that showcases the FIRMS API and web services. And then once our final speaker has finished with his presentation and live demonstrations, what we'll do then is we will transition to our final optional polls, and then we'll jump directly into the Q&A session. Just one final note about the Q&A. What we'll do is we'll try to answer all the questions within the time allotted, and our panelists should feel free to, answer any of the questions as we go along within the Q&A panel. But if we are not able to address your question during the Q&A or the extended Q&A at the end, our speakers will be able to follow up with you, offline. With that, it is my pleasure to introduce today's first speaker, Diane Davies. So at this point, I'll stop sharing my screen, Diane, and you should be able to share your screen at this point.
Great, thank you, Jennifer. Can I just check you can see my screen all right?
Yes, I can, thank you.
Okay, good. Well, hello everyone. It's a pleasure to be here to share with you some of the recent updates to FIRMS and the new expanded user interface. So FIRMS is the Fire Information for Resource Management System. And as you may well know, we have 2 independent platforms for FIRMS. These are related. We have FIRMS Global and FIRMS US Canada. FIRMS US Canada is the result of a partnership between NASA and the US Forest Service and was launched in 2021. Today, we're going to primarily focus on FIRMS Global, but if you're interested in FIRMS US Canada, please stay tuned, as all of the features and tools that we show today will be for FIRMS Global and will soon be available on FIRMS US Canada. I do just want to say that VIIRS is part of NASA's Land Atmosphere Near Real-Time Capability for EOS, or LANCE. And as it says here, it enables access to timely global satellite imagery and active fire detections from multiple satellites. So both platforms have the same components. We have a fire map, an interactive fire map, which we'll be demonstrating today. We also make available active fire data, which enables users to download the latest active fire data in shape, KML, or CSV format. That's for the last 24 or 48 hours, or the last 7 days. There's an email alert service, which provides notifications of active fires detected in your chosen area of interest, and these are available in near real time or as daily or weekly summaries. The archive download enables you to download data from the full archive of MODIS and VIIRS active fire data for your chosen area of interest. And then there are a number of web services, and Otmar will talk about these after we've given you a demonstration of the user interface. So before we dive into our live demonstration, I quickly want to go over what an active fire means on the ground. Now, when you first open VIIRS, it often looks like there are huge areas that are completely on fire, and this is simply due to the relative density and symbol size of the data at this scale. So this is what it looks like, and you can see Madagascar and Mozambique look like they're totally on fire. But when you zoom in, you start to see that there's a few gaps between the pixels. Sometimes they merge together. But if you zoomed in too much, it can look like the entire pixel is an active fire. However, the hotspot or active fire could be anywhere within that pixel. So if you're looking at a VIIRS pixel, the fire could be anywhere within that 375 meter pixel. If looking at MODIS, there could be one hotspot anywhere within that 1 kilometer pixel, or there could be multiple fires. It doesn't mean that the whole, whoops, oh, sorry, I think I missed one. It doesn't mean that the whole pixel is burning. Now, I've just included this figure to give you a better understanding of the different pixel sizes of the data that you can find in VIIRS. So on the very bottom left-hand side, there's a little red square. That's the pixel size for the Landsat active fire data. Now, please note that these data are only currently available for the US and Canada. And although Landsat has a high spatial resolution of 30 meters, it has a low temporal resolution. We only get Landsat observations once every 16 days as the satellite goes overhead. But because we use both Landsat 8 and 9, we do get observations every 8 days. And these are available in the global VIIRS, but only the coverage is only for the US and Canada. The next square is the VIIRS 375 meter pixel. And the one up from that is the MODIS 1 kilometer pixel. And these have been the workhorse of VIIRS, the active fire data that we provide through VIIRS for a number of years now. Recently, we've added geostationary data, and that's represented by the purple 2 kilometer square. This is for GOES imagery, but the same applies pretty much for the other geostationary satellites that we'll be mentioning. Just to say, this is the resolution sub-nadir. So as you move away from nadir, then the pixel size gets bigger. And we'll talk more about this as we go through. But I just wanted to make that clear. And now we're going to talk about the expanded user interface. And I'm going to hand over to Jenny.
Thank you, Diane. And can I confirm that folks can hear me, please?
Yes, we can.
Thank you.
Yes.
Well, good morning, afternoon and evening to our participants from me as well. First of all, I wanted to quickly review the objectives of the expanded user interface. These include supporting an increasingly diverse set of users, as well as increasing both the visibility and access to the multiple products and services available in VIIRS. We also are providing these distinctive interfaces for different user levels, different use cases, and also to provide access to prototype products, and finally to enable additional filtering, analysis, etc. And as you can see on the right, this is the main menu. Again, we still have the basic and advanced mode, although with added utility. There's also a burned area smoke and aerosols, the US, Canada, the fire alerts, and a downloads mode, and the Wildfire experimental mode that will capture prototype products. And now I am going to share.
That looks great. Thank you. Thanks for your patience, everybody.
Okay, perfect. So let's dig in. And as Diane mentioned, we're highlighting the global firms today. So I'm going to share a couple of examples from Chile and from Canada. The default mode when you first open firms is the basic mode. And this provides quick access to active fire data, dynamic imagery, and useful overlays. This is really designed for new users in mind. The menu for each mode will look similar with these accordions on the right-hand side that contain different themes and context layers. Each accordion has a question mark that summarizes what is in that accordion, and there's also a plus and minus to expand the accordion. When you click on the 3 horizontal lines, you will see the main menu, and I'm going to demo the basic mode in the burned area, and then Diane will demo the smokes and aerosols. Okay, so again, we are going to use an example from Chile in South America to demo the basic mode. Currently, we are looking at active fires from multiple polar orbiting satellites in the last 24 hours. For this demo, we are going to back up to February of this year, when Chile experienced significant wildfires in multiple regions. We are going to look at the trajectory of these wildfires over multiple days, plus other layers to inform the impacts. The VIIRS region of Chile experienced extensive wildfires in multiple provinces. And so we're going to use the location tool to dig into this area. So I will type VIIRS into the search. And just to note, there are a few options here. You could use your current location or saved locations. And let me zoom out slightly. So this is the region right in here. And I'm going to set up a timeline to look at the trajectory of the fires. This is the timeline feature on the bottom. We are going to select 1 day and back this up to February the 1st. Okay. You could also use the calendar drop down here for the same effect. As you can see, there's minimal wildfire activity on the 1st of February. The active fires that we are displaying are generated from VIIRS on board SMPP and NOAA 20, as well as MODIS on board the Aqua and Terra satellites. As Diane mentioned, there are Landsat active fire data, but are currently only available for the continental US and parts of Canada and Mexico. You can also toggle on and off the active fires with this button here, and you could change the opacity of the active fires. The default is the simple mode, but you could also look at the active fires, which will be color-coded by time since detection using this time-based option here. I also wanted to discuss the prevalence of smoke associated with wildfires. There's massive amounts of smoke that these wildfires can generate that impacts air quality, human health, etc. And the satellite imagery, particularly true color composites, which are similar to what human eye would see, will be helpful in identifying smoke. So in the dynamic imagery accordion, we have true color composites from VIIRS on NOAA 20 and SMPP, as well as MODIS on Aqua and Terra. These have daily coverage and a spatial resolution of 250 meters. If we toggle on the MODIS Terra true color composite, you will also see that there are clouds to the east and the west of our area of interest on the 1st of February. I'm also going to turn on in the overlays the borders and roads, the detailed version, to provide additional context to the active fires. Now, if we move on to the 3rd of February, using this button down here, you can see the expansion of the fires, as well as this massive amount of wildfire smoke being generated. I just wanted to highlight again that these are clouds to the northeast and to the southwest of the fires. Now, if we set this to 2 days and we forward this to, let's see, we'll go to the 13th of February, there's less wildfire activity, as you can see here. However, I also wanted to note that passive optical satellites such as MODIS and VIIRS cannot penetrate or see through clouds. And so the 12th of February was a particularly cloudy day, which may have reduced the detection of wildfires. Moving on, you can see that there is an increased amount of wildfires. Again, let me zoom in slightly. In this area, all the way through the 19th of February and beyond. So again, for this demonstration, we use the true color composite imagery from MODIS on the Terra satellite. We could also have used the MODIS imagery from Aqua, as well as VIIRS on SMPP and NOAA 20. The benefit of the Terra MODIS imagery is due to the morning overpass, and there is generally less cloud contamination in the morning. Okay, I quickly wanted to highlight these tools along the bottom. There is a measurement tool for measuring area and distance in a couple of different units. Ready access again to the location tool. You can get easy access to the layers here, the timeline, which we have used in this example. There are a couple of different options for capturing and sharing the information. You could take a JPEG, a GeoTIFF, a PNG of the screenshot and share that. You could also generate a URL and embed that in emails, for example. There's an extensive help library. And there is also the option to maximize the screen so you can see more of the map. Okay, secondly, I am going to move on to the burned area mode, which is new in this expanded user interface. I have one already loaded here. For easy access. Again, it defaults to the basic mode, but you will select the burned area mode here. And for this demonstration, I'm actually going to focus on 3 accordions: the harmonized Landsat Sentinel imagery, the MODIS burned area product, as well as the dynamic imagery down here. For this example, we will use the Donnie Creek wildfire, which occurred in May and June in British Columbia, Canada. So again, using the location tool, I will type Donnie Creek here, and then we will zoom into this area. Okay, first of all, we are going to look at the trajectory or the pattern of the wildfires in Donnie Creek, and then we'll look at the area burned. So for this demonstration, I am going to select 4 weeks down here, and I'm going to set the date to June the 12th. Okay, and up here, I'm now going to toggle on the active fire data for this 4-week period, from the 16th of May to the 12th of June. And like the basic mode, the active fire data are from MODIS and VIIRS. Again, the Landsat active fire data are only available for the continental US and parts of southern Canada and northern Mexico. You could also display this by time-based and color code the active fires based on hours or days. You could also use this custom mode to display the active fires by confidence by FRP, for example. Okay, so again, this is the trajectory of the wildfire over this 4-week period, but we're also interested in the area of land burned. And for this, we will use the dynamic imagery accordion, as well as the harmonized Landsat Sentinel imagery. So I am going to turn off the active fires for right now. I am going to select one day, and I'm going to shift the date to the 7th of July, which is when much of the wildfire had died down. In the dynamic imagery, I am going to turn on the Modus Terra false color composite. Okay, now in the basic mode, we use the true color composite to look at the active fire and the smoke. Here, we're using the false color composite because false color composites are very useful for identifying burned area. And this is due to the characteristics of the burned area. As you can see, the burned area pops out as bright or dark red in the shortwave infrared when displayed as red. Again, the morning overpass by Modus on board Terra tends to be less cloudy compared to the afternoon overpasses of Aqua, as well as VIIRS on SMPP and NOAA 20. For example, if I toggle on the VIIRS NOAA 20, you can see that there is certainly more cloud in the afternoon. You can also actually see this bright pink flaming fire front right here. Okay, let me switch this back to the Modus. And then we will also make use of the HLS, the Harmonized Landsat Sentinel imagery, up here. A few quick notes on these data. So these are composites that are dynamically generated, and as such, they can take a little longer to load. There's a 2 to 3 day lag between the collection of the imagery by the satellite and their availability in firms. Today's the 18th of October, so imagery from the 15th of October and earlier is available. Additionally, due to the narrower swath width of both the Sentinel and Landsat satellites compared to, for example, the VIIRS and the Modus satellites, it takes longer for these satellites to revisit the same spot on the Earth and complete coverage of the Earth, as Diane mentioned earlier. Between these two satellites, the Sentinel-2 and the Landsat, there is about a 5-day revisit time on these. There are also 4 different imagery composites available in firms. There is a true color and false color composite from Sentinel-2, as well as a true color and false color composite from Landsat 8 and 9. As you can see, I've just toggled on the true color composite for Sentinel-2 for the 7th of July, and the burned area is not very distinct. In fact, it's quite tricky to delineate from the background. This really highlights the utility of the false color composites for identifying burned area. Because if we zoom in slightly, and now put on the false color composite, and again, we just have to be a little patient because these are being dynamically generated. You can really see how the burned area pops out in the false color composite. Now, additionally, while Modus has a spatial resolution of 250 meters, if I zoom in slightly here, and again, we will just give it a moment to catch up. You can see that now we can actually delineate some of these linear features such as roads, as well as different characteristics of the burned area. And just to highlight this, if I now click off, toggle off the Sentinel-2 imagery, you can really get an appreciation for the difference in the spatial resolution. Finally, I want to quickly highlight the Modus burned area product, which can be helpful to inform the extent of the burned area. This is NASA's standard science product, and it is available with a 3-month lag. Let me zoom out here and toggle on the burned area product. Now you can see that a significant amount of area burned in May and very little before May. Just to note, you can toggle on the different months here. You can also change the opacity of the burned area here. You can change the color of the burned area, and you can fill the burned area, or you could also just look at an outline of the burned area. Okay, much of this area, which is highlighted, which appears as red in the Modus false color composite, burned in June, and so this will be added to the burned area product soon. However, to confirm this area burned in June, I'm going to quickly pop back on the burned area, the active fire data for the 11th of June, and select 11 days here. And let me pop this back on. And now you can see that, yes, a lot of this area was an active wildfire for these 11 days in June. And with that, I will pass it over to Diane.
Thanks, Jenny.
Let me just stop sharing.
There we go.
Okay, perfect.
Can I confirm that you can see my screen?
Yes.
Great. Okay. Well, thanks, Jenny. So as Jenny said, I'm going to give you a quick overview of the smoke and aerosols mode. So again, I've gone to the 3 horizontal lines at the top and clicked on smoke and aerosols. So this mode subsets the areas that we consider most useful for tracking the transport of smoke. When you first open this mode, the aerosol index from OMPS, or the Ozone Mapping Profiler Suite on board SUMI MPP, will be displayed. OMPS aerosol index is useful for looking at smoke, but it is an indicator of aerosols, which is also useful for tracking volcanic ash from volcanic eruptions and dust from desert storms. And I feel the need to emphasize that these aerosol index values can be used for much more than fire, because often a dust storm could look like a smoke plume to the untrained eye. So I've opened I've gone to the date 30th of September. And in the Northern Hemisphere, you can see these are aerosol index values from smoke that's come from the Canadian wildfires. But down here off the west coast of Mauritania, we also see high aerosol values. But these are actually dust from the Sahara Desert and not smoke. And to illustrate that point, what we could do is we can put on the fire data, and you'll see that there's no huge sources of fire which could cause smoke. And the other thing that you could do to double check is you could turn on something like the MODIS corrected reflectance imagery. And so if we just zoom in here, and if I change the opacity on the aerosol index, you can actually see some of the dust blowing into the ocean. So I just wanted to highlight that because we're using the aerosol index to track smoke in firms, but there are other applications too, and I just wanted to make that clear. All right, so I'm just going to switch gears now to actually look at some aerosol indices that demonstrate smoke. So for this example, I've selected June the 6th. So I used the calendar to select June the 6th. And this was a date when the smoke from the wildfires in Canada caused a dark orange haze that covered New York and much of the eastern seaboard. And since aerosols can be suspended in the atmosphere and carried in prevailing high altitude wind streams, they can travel great distances from their source impacting air quality in areas far from the source of the fire. And in this case, to see where the smoke originates from, we'll turn on the active fires. In this case, I'm going to put on a week's worth of active fires. So down in the timeline, the blue, it would help if I turn the fires on. The blue here shows the active fires, and the grey shows the date of the overlay in the imagery. So if I just move this along, you can see we're going backwards now to see where the smoke and aerosols came from. So you can either use this grey time slider, sorry, I've gone back too many days, grey time slider, or you can use the arrows here, but they will go back a week. So if we go back a few days, I mean, actually what happens is that it goes over the poles, but okay, this is, I do apologize, I've gone the wrong way. So, okay, so here we are. I do apologize, it's because I've got a week selected here instead of a day. So my sincere apologies. All right, so if we go back, you'll see how the smoke originates from Canada. There we go. And if we zoom in here, you can see that the smoke originates from the wildfires in Northwest Territories and the northern parts of British Columbia and Alberta. Now, you may have noticed that there are two OMPS aerosol index layers. These are related, separate but related. The OMPS aerosol index range is smaller. It goes from 0 to 5, whereas the OMPS aerosol index pyrocumulonimbus layer extends by a factor of 10, reaching to 50, which allows us to more readily identify pyrocumulonimbus events. A pyrocumulonimbus event is a fire-caused or a fire-enhanced thunderstorm that in its most extreme form pumps high amount of smoke and other biomass burning emissions or aerosols into the lower stratosphere. And Canada this year has seen a record number of pyro-CB events. So I'm going to just show you one of these events. I've just changed the tab and I'm now showing you the 16th of September 2023. And what we've got here is this is actually a pyrocumulonimbus event. But first of all, we're looking at it with the OMPS aerosol index on. But you can see that the values go up to 5. If we zoom right in and put on the corrected reflectance imagery is on. If I turn this off or to change the opacity, you can see that we have this huge smoke, fire-induced smoke, a storm, okay? And if we turn on the OMPS aerosol index, but if we put on the OMPS pyro-CB layer, we can see that we've got some higher values here. So I'm just going to turn this layer off again, and you can see that we've got these yellow values. Now, I'm reliably informed that anything over a value of 10 is quite probably a pyro-CB event. So if I just adjust this to 10, then you can see that this is, well, in this case, it was a pyro-CB event. And from here, we saw a lot of smoke be transported all the way to Europe. Okay, so that's what I wanted to show you briefly on smoke. What I want to do now is I want to move and just show you a few of the features in the advanced mode. So the advanced mode has all the firm's data layers. So everything that you've seen so far will be included here. And I just want to highlight some of the additional customization that you can do when viewing active fires. I want to give you a quick tour of the geostationary active fire data and show how it can be useful for tracking the progression of a fire using the sub-daily timeline, and briefly mention how to use the orbit tracks. So to start with, Jenny's already gone through simple and time-based. She also mentioned custom. So custom allows you to turn individual layers on or off. You can also color code individual layers. So if you wanted to highlight a particular data layer, you could choose to do that. Up here on the pre-select, you can choose to display the fire by either confidence or fire radiative power. Fire radiative power shows, gives an idea of the intensity of the active fire during satellite overpass. And we're going to zoom in here to some of the fires in the Northern Territories of Australia, where there's some big fires burning. So this pre-select will work for any layer that you have checked. Alternatively, if I go back to fires, you can opt to customize one layer at a time. So in this case, I'm looking at VIIRS, NOAA 20 data, and I might decide that I'm just interested in daytime fires. So I can turn the nighttime fires off and I'll just see daytime. Or alternatively, I can turn the daytime fires off. Or if you want to, like I showed before, you can actually change the color to see the difference more readily just from viewing the data at a distance. Okay, there we go. All right, I'm just going to reset this to the default. Okay. All right, let me zoom out. So this was a very large fire that occurred pretty quickly. I'm going to change the date range to 1 day. And you can see, so this is for today, and you can see that there have been a number of active fire counts today. In fact, this fire stretches I think it's 300 kilometers. It's a very big fire. But what I'm going to do now is I'm going to turn on some of the geostationary data for you to look at. But before I do that, I just want to show you what the geostationary data looks like. So let me just, oops, sorry about this. Let me just go to this tab. Sorry, I'm having trouble with my the bar at the front. Tell you what, let's just do this. Let's just go to the advanced mode here and start again. If I just remove this, I'm sorry about this. I can't see the last tab that I had set up ready for you. Okay. So, all right. So if we were to go to the advanced mode, there we are, and look at the geostationary data. Here we are. I'm just going to open this accordion here. And what I want to do is I want to show you the different geostationary layers. Okay, so I briefly mentioned geostationary data later on. We had a lot of requests to add this data into FIRMS. I should just say that it's not NASA data, and it comes from various space agencies, including NOAA, EUMETSAT, ESA, and JAXA, the Japanese Space Agency. And you can find out more about each layer by clicking on these individual eye icons on the right-hand side of each layer. And that applies for all of the layers within FIRMS. So geostationary satellites orbit high above the Earth's equator at speeds equal to the Earth's rotation. So they can provide continuous coverage for an area over time. And to illustrate their approximate coverage, I'm going to turn on the data from GOES, which covers the Americas. If I put these on, it's slightly brighter. And you'll see that we actually have 4 layers here. That's because we have 2 different algorithms. So we have data from GOES 16 and GOES 18, and we have data from 2 different sources. I'm not going to go into that now, but you can find out more in the information layers or in the FIRMS frequently asked questions. Covering Africa and the Middle East, we have the Meteosat. We have data from Meteosat 9 and 11. And it's just taking a little while to load. And for Southeast Asia and Australia, we have data from Himawari, which hopefully will load. Okay. There we go. It just seems to be taking a little bit of time. All right, so I'm going to turn, there we go. There it is. All right. So I'm going to turn the Himawari layer on, and we're going to zoom straight back into this area that we were looking at in the Northern Territories of Australia. And I'm also going to put on the VIIRS SUMI MPP data. In fact, I'll put on all the polar orbiting data. Okay, we'll just wait for this to resolve. And what I want to show you, what I want to illustrate now is, well, actually, before I do this while it's still loading, I just want to say that the geostationary data is particularly useful because it has a high temporal resolution. So it provides data every 10 to 15 minutes within 30 minutes of satellite observation. And this is particularly useful if you don't want to have to wait for the next polar orbiting satellite to get information. The downside is that these data have a much lower spatial resolution. They have a resolution of approximately 2 kilometers. Let's just see if we can zoom in here. Maybe this will be better. 2 kilometers, and I'll just illustrate that here. So here you're looking at, in red, the data from VIIRS. So this data is 375 meters. Let me just close some of these tabs and see if that helps. Okay, but hopefully you can see that these yellow pixels are very large compared to the red VIIRS pixels. And here we are, you can see just how small they are. And so we've actually labeled the geostationary data as beta because we would prefer users to use the polar orbiting because we feel like it provides more reliable information. But and also the other thing that I should just mention is that the GOES NOAA FDC algorithm is still being developed, so that might change. So there are a few things, a few caveats to consider when using the geostationary. So we'd say use it with caution, but in instances like this, when you have a huge fire, it can be very useful for looking at the trajectory of that fire over time. So here we're looking at 1 day of data, October the 18th. If I change that date to October the 17th, what I can do is we can use the sub-daily menu to look at how that fire progressed. So if I click on sub-daily, just to the left, to the right of daily, it automatically defaults to a 4-hour window. And here the time is set to 1850 UTC, and I'm going to change that to 150 UTC. Okay, I'm going to keep it on the same date. And as I say, at the moment it's 4 hours, and I can use the time slider to move this along to look at the next 4 hours. There we go. You can see now we've got data from Himawari, and we will have data from VIIRS NOAA 20. Okay, so this is particularly useful if you want to look at the progression of a fire. You can change this time interval to 1 hour or 50 minutes or whatever you want to do if you want to really identify how a fire has progressed. The other alternative, if you're interested in that, is you can also, as Jenny showed earlier on, you can look at the time since detection for a fire. But this, and that would obviously only work if you're looking at 1 day, but this sub-daily time interval is particularly useful if you want to look at how a fire has progressed over time. All right, and with that, and in the interest of time, I'm going to hand over to Otmar, who's going to talk about the web services.
Okay, hello everybody. Can you see my screen?
Yes.
Okay, so my name is Otmar Olshina, and I'm one of the software developers on VIIRS. And today I'll be covering web services, which is another way for you to get VIIRS data and use it in GIS applications such as QGIS, ArcGIS, Google Earth, or in your download scripts. So to access our web services, there is a direct link on our front page here. We have one for global and US, Canada, but today we'll be discussing global. They're pretty much identical. And once you select the web services option, these are the different services we provide. So before I start, I'll mention that we have tutorials and examples at the bottom. So everything I'll be discussing today, you can easily find the step-by-step instructions with pictures, how you can establish different services. For example, a web map service, web feature service using ArcGIS or QGIS, or using KML for Google Earth, and also links to examples for our code and some other suggestions what you can do with our data. So let's first discuss the CSV, KML, and Shapefiles option. This is our oldest data service, and it generates downloadable files for various areas of the world. They are updated once an hour, and you can easily download it and use it in your GIS applications. So for example, Shapefiles are great for ArcGIS or QGIS. Google Earth KML, as it states, it's good for Google Earth. And then text files, you can either open in your text editor or Excel spreadsheet, or do some additional work in your ingest script. For our map services, we offer a web map service. So before anyone can actually use our map services or API, we ask them that they need to register for a free map key, which is very easy to sign up for. You just put your email address here, and you will receive an email that will look something like this, where at the top you'll have the map key that you can readily use within our application, with also links and references to different tutorials, which you can also find from the page, as I mentioned, the one for tutorials. But this is just to give you a quick start. And so for those who don't know what web map services are, it is essentially a service that generates a map for you of the most recent fires. And a lot of the GIS applications, they have easy way to integrate this type of service in there. And just to showcase how easy it is to put this, for example, in a GIS application, I'll paste my key here and take this string. And as I mentioned, this is in our tutorial, so you don't have to worry about missing anything. And I'll open here. I have already opened ArcGIS Online. I'll try to add a layer from URL. Paste the URL to firms, including the key. Please don't use this one because I'll be disabling it after the webinar. And now it will give you the list of available layers for that specific layer category. So in this case, let's say we want to visualize MODIS 24 hours. And I'll do that because they load much faster. And now here you have it. So this is how easy it is to add our fire data to a GIS application. Now, similarly, we offer W feature service, which is just provides the actual additional information about fires, containing geospatial value that the GIS application know how to integrate. So all this data now becomes available to you within the actual application, so you can do additional analysis. Now, for those who are interested in writing their own scripts, we have API programming or application programming interface. Again, the map key reference is at the bottom, so if you need to set it up, and it works for API and the map services. And at first, I'll quickly show the data availability, which will give you. Let me copy this again here. And display results. And this will give you the list of the data sets that we have with their temporal ranges. So most users are generally interested in the NRT because that's the most recent data. And for that, you can just go to our, for example, area or country API REST endpoint, where you can subset values by, area of your interest, selecting the appropriate source. This includes the ultra real-time and real-time data, so you will get the most up-to-date data. Unfortunately, that mostly applies to North America for the ultra real-time and real-time for now. And now you can get the data for that specific region. Now the date is optional, so if you don't provide the date, you will get the most recent data for that region up to 10 days. If you do provide date, then you can query for a specific date area that you are interested in. But for many, this is probably the easiest and the best way to get the most recent data. And similarly, we have one for country, where they can select a country and it will subset the data specific to that region. We don't recommend using it for big countries such as US, Canada, China, or Russia, because their polygons are a little too large, so the query may time out on you. So for those, you might need to use download feature if you want historical data, or just use some other subsetting. But for all the other countries, this is actually very efficient and works well. And we also have one for KML fire footprints that show rectangular area where the fire detection is. And the newest addition that we have in our system is under tutorials, you can find section for Fire Data Academy. And now this is for those who want to start learning or using Python to download our data sets. So even if you don't have much programming background, we believe you would be able to follow this and easily implement the solution using Python. Now, some of you might be a little bit scared to use Python because you might need to download it on your computer and set it up. But Google offers a great virtual Python environment, which is free. If you have a Gmail account, for example, you can easily sign up for it. It takes less than a minute. The step-by-step instructions are included here. And once you sign up, you will get an environment that looks like this. So in your browser, you can start writing Python code. You click on this play button and it will execute it for you. So this takes away a lot of installation processes that you will have to otherwise deal with. So if you just want to start learning about Python or using it for some of your ingest scripts, you can start doing it here. And you can also save your work and share it with your colleagues. Now, with that in mind, we created several little tutorials which will show you how you can use firms data, how you ingest it, how you can subset it, teach you about the variables, and with very basic code to give you the idea how you can quickly get more out of our data, including applying a time zone. So this way you can have data sets that corresponds closer to your country as far as like when the data was detected. And at the end, we just have a little quick summary. So as you see, it's just a few lines of code and you already learned how to subset. Similarly, we have one for data visualization. So this will actually teach you how to color code fire detection based on time since detection, and also apply a background map. So at the end, you can end up with something like this, showing Canada wildfires from July 12, 2023, and color-coded by 4 different colors. Now, with that in mind, I think that concludes our webinar, and now I'll go back to you, Jennifer.
Okay, great. Thank you, Otmar. At this point, I'm going to open the last set of polling questions really quickly, and we're going to go ahead and get started with our Q&A, because we've got several questions in the chat and then quite a few in the Q&A as well. So I'll start with a couple in the chat and then we'll take it from there. All right, let me open this poll. All right, poll's opened. All right, let's take a look here, everybody. Okay, so one of the, let's see, I have to scroll up. Thank you for bearing with me. Okay, so the first question was asked pretty early on. Is there a possibility to upload your area on NASA firms for mapping?
Otmar, do you want to respond to this?
I'm sorry, could you repeat? I was looking over the questions and missed what you were saying.
Sure, no problem. Is there a possibility to upload your area on NASA firms for mapping?
You mean if it's for like the downloads and alerts, that's something we will try to do very shortly, because yeah, that's a feature many users have asked for. So I hope so, we'll have it soon.
Okay, thank you, Otmar. Let me just take a look through the chat to see. I don't want to try not to miss any of these here. Okay, so let's see. So the next question is, Is it possible to access the NDVI of our interest area for mapping by using NASA firms?
That's a great question. We don't currently include the NDVI product in firms, but if you have a good reason for wanting to have that from a fire perspective, then by all means, please write to us and let us know the rationale for it. With these additional modes, we're trying to accommodate more user kind of requests for active fire data. You can certainly view it in NASA Worldview, which also has the active fire data from firms. But if it would be useful to have it in firms, then please write and let us know, because really any of the imagery that's available through GIBS, Lance, through NASA's near real-time capability, we could put into firms, but obviously we don't want to replicate what Worldview does. We are specifically focused on people that are looking at active fires and want to manage them.
Yes, thank you, Diane. And I can follow up with that participant offline with some links, because not only Worldview, but there are also some tools available through our Oak Ridge Data Center that allow for the processing and visualization of NDVI for your region of interest. So I'll follow up offline as well with some information. The next question is, what determines if it's an active fire versus one that has been contained or eliminated?
So I tried to answer this in the chat, and the bottom line is we can't tell from the active fire detections, the satellite-derived active fire detections. I did mention in my message that in firms US Canada, we have some fire alerts. These are kind of big orange blobs when you first go into firms US Canada, and these are active. This contains information on wildland fire incidents from agencies such as IRWIN, the Integrated Reporting of Wildland Fire Information for the US, and from a collection of information from places like the Canadian Interagency Fire Centre and the Natural Resources Canada for Canada. And that will provide some information on whether or not the fire is contained or not. But from the satellite data alone, we can't tell.
Okay, thank you, Diane. I'm sorry I missed that. I do see you answered at 2:48. I was starting at the top. Okay, so let's see. The next question is, and I kind of answered this, but if you could confirm that whether or not the functionality that was featured this afternoon is available outside of the US. And I said, yes, the functionalities being featured are available outside of the US, but if you can confirm whether there are any other considerations to address that question.
You're correct, Jennifer.
Okay,
yes.
Thank you. Okay, will the Landsat hotspots be seen in Europe at some point?
That's a great question. It's something that we would like to see, but it's not anything that's going to happen in the short term. Currently, we pull direct broadcast data for Landsat. It may well be a possibility in the future as we move to the cloud, but it's not on the cards just at the moment. But stay tuned.
Okay, thank you, Diane. Our next question is there a way to download overlays as shapefiles, for example, various burned areas?
There is a website at the University of Maryland which you can go to get those shapefiles. We don't make them available through firms, and I'll pop that link in the chat or follow up with you afterwards. Yeah.
That would be great if you could do that. We have entered we ran a little bit late on the presentation, so we're currently in the extended Q&A session. So the next question is, does aerosol index include VOG from volcanic eruption, as we have both wildfire smoke and VOG in Hawaii? My initial follow-up was that I wasn't sure whether you could really distinguish between the VOG and the wildfire smoke using the firm's aerosol index layer, but I'm sure that our speakers can lend some additional insight there.
I am not entirely sure. I mean, we can certainly detect ash plumes. If that's the same as VOG or not, I don't know. I'm not enough of a specialist. Jenny, Otmar, I don't know if you've got any additional insights.
No, I would have this similar response, Diane, but an interesting question.
We could follow up with you afterwards.
Okay, wonderful. Thank you. The next question I answered, which was whether or not, point that the application is user-friendly. Are the access rights special or open to the public? FIRMS is freely and openly available to the public. If there's anything else to add to that from the speakers, please feel free to elaborate. All right, and if not, moving on, is WMTS an option for tiles to overlay over Bing or Google Maps rather than forming lots of MS requests that clip to tile bounds?
Mark, do you want to answer that question?
I'm sorry, could you please repeat? I've been paying attention to the other chat here.
Of course. Is WMTS an option for tiles to overlay over Bing or Google Maps rather than forming lots of WMS requests that
Yes.
clip to tile bounds?
Yes, you should be able to use that. That was the intention, so it's much easier to set up than using WMS.
Okay, wonderful. Thank you. Will firms add VIIRS data from the NOAA 21 satellite?
Yes, that's the plan. Once it starts being processed by NASA, we will make it available.
Thank you very much, Diane. The next question is, give me 1 second here. All right, for a burned area, excuse me for a moment. Is there a way to clear cloud cover?
I wish there was. That's a great question. The MODIS burnt area project that Jenny demonstrated is a 45-day project. So it tries to compensate for cloud. And no, with optical imagery, we can't see through cloud. And that does often obscure active fire, burnt areas, and you have to wait for a clear day. So unfortunately, no.
All right, let's see here. I don't see any additional questions in the Q&A panel, but I'm just scrolling through the chat to make sure I haven't missed any. So bear with me momentarily. It's basically just a scroll on my part here. Let's see here.
Jennifer, I can answer an additional question that I'm seeing in the chat, if that's helpful. The question was from Lorette. Please may the Donnie Brook example be repeated for a site in Central Africa where Landsat is not available? What are the burned area options? And yes, Lorette, you could replicate the example in Africa. I did not use the Landsat active fire data because they're not available in the area that I was using in Canada. The harmonized Landsat imagery are available throughout, and so you could replicate exactly what I did for a site in Central Africa. One additional note is that the characteristics of the vegetation could impact the burned area signature somewhat. And so what that means is if the area greens up very quickly after a fire, it may not pop out as much in a false color composite.
Okay, thank you, Jenny. So the next question is, let's see here. And again, if it was answered later in the chat, I can't see that at this point. Can we use for the fire detection system to know the impact of fire on the nearby water bodies?
No, not directly. That would be something that you would have to do, combine different data sets or use ground-based measurements. You can only use it to look at the extent of fire. And I guess the type of information that can be provided through FIRMS could be used in a modeling approach, but no, not just as it stands.
Okay, thank you, Diane. The next question, and I hope I am going to interpret this correctly. And if not, if the participant's still online, feel free to clarify or add additional information. So for the hotspots that are not wildfires, how do we inform NASA about them? For example, setting up an alert associated to industries.
So thank you for that question. And in the case of static fires, we are actually currently discussing how to manage those within firms. So it is something that we are currently working on. And Diana or Otmar, if you want to add any additional information.
No, that's great. Thanks, Jenny.
Okay, perfect. Thank you, Jenny. Thank you, Diane. So the next question is if you could maybe quickly go over again how you would pick up the last 24 hours of data using firms. I think this user might be having difficulty being able to render that page for the last 24 hours of fire data. But if I do not have that correct, please do let me know.
If I quickly share my screen, I'm not sure if this is going to help. If you want to see data for the last 24 hours, you would go to the basic mode and select this 24-hour button, and that will show you the active fires for the last 24 hours. If you want to download the data for the last 24 hours, you can go to the active fire tab here, and you can download data as a shapefile for one of these regions or for the world. So that's for MODIS, VIIRS, and Landsat. I hope that answers the question. If not, please get back in touch.
Yes, thank you so much, Diane. Okay, so the next question is, can you go over which aerosols are detected and put on firms?
So currently we only make available the OMPS aerosol index, which is a unitless, which has unitless values. You can read more about that in the information tab associated with that layer. We are considering putting different aerosol products into firms. And if we do that, it would probably be the VIIRS dark blue, I want to say dark target. There's a couple of other ones we're discussing whether or not we should put those in, but currently it's just the OMPS aerosol index.
Okay, thank you, Diane. So the next question is, are there any plans for IR or SWIR-based imagery data in the future or being added to future satellite missions?
So I'm not sure I'm 100% clear on that question, but there are already both SWIR and IR bands in the imagery and that we demonstrated today in the MODIS and the VIIRS and the harmonized Landsat imagery. Diane, do you want to add anything to that?
No, Jenny, that's good.
Okay, the next question kind of is along the same lines as what we were just talking about, and it might need to be addressed offline, whether or not there's any new algorithm that's presently available that would allow us to differentiate between industrial fires and biomass burning events. And I think that's maybe something we have to take a look at after the webinar, unless you have some input you would like to share on that question.
No, not currently. Generally, that type of information is obtained by comparing sort of a land cover map with the active fires.
Yes.
So that would be the approach I would think you could take.
Okay, and so the next question is a good one. Can you set up email notifications for geopolitical regions, a state or county?
Currently, you can't do a state or a county, but guess that's something that we might consider for the future. You can certainly do protected areas, and I guess if, as Otmar said, we enable people to upload their own areas of interest, that might be a way forward. But currently, no.
Okay, thank you. Thank you, Diane. And there was a comment in the Q&A about, being able to provide these sessions in multiple languages, and so the closed captioning capability does allow for 6 different languages. So if I were to, this is a very good comment. So I think if I were to do that, would try to target a specific, French, Francophones, it might be kind of difficult. So whatever language is selected would be the language that appears on the screen for closed captioning for anyone who invokes it. And I did think it was available on an individual basis, but it seems from one of our attendees that it just appears as English unless I were to select French. So that's something we can certainly look at moving forward. And I really appreciate your feedback on that. Thank you. I'm just looking to see if there's anything else in the Q&A because we have just a couple of minutes left here. Okay.
Jennifer, I see another question. Will the VIIRS data from NOAA 21 be incorporated?
Yes, we addressed that one.
Okay.
Yep. Thank you. Thanks so much, Jenny. So there is another question actually in the chat. And so the question is, in India, agricultural fire is a big cause of pollution during the winter. So is this system useful for detecting those fire locations?
I'd say it is. I mean, often firms' imagery is reported in the news when you have those huge agricultural fires. Well, not small agricultural fires that cause a huge amount of smoke and smog. But I guess in terms of identifying exactly, pinpointing exactly which fields or which fires the smog comes from, it may be of limited value due to the spatial resolution of the data. But certainly you can clearly see the smoke and smog that come from those agricultural fires in winter.
Okay, thank you, Diane. I was just getting ready to respond, but I'll enter this into the chat in just a moment. So the question is whether or not this afternoon's webinar was recorded. Yes, today's webinar was recorded. Yes, it will be posted online, both to the NASA Earth Data website, as well as to our NASA Earth Data YouTube channel, where we have over 350 data discovery and data access webinars and tutorials and some specialized playlists as well. I will also follow up with all registrants and send you a link to both the recording and to the presentation slide deck. And let's see here. I'm not sure whether there's a possibility to, we currently don't have a firm's training, professional development training that would result in a certification, but certainly that could be something that perhaps is considered down the road. I did see that note earlier on and I wanted to address it really quickly. I don't know if Diane, or that's a very good idea, or Jenny had any additional points for that, but I think it's a pretty small team. I'm not sure that currently we would have that kind of capacity, but I do think that that is a very good point in terms of building capacity. Let's see if there's anything else. Okay, I'm going to jump back down to the Q&A. I think with that, I don't see anything additional, and we are at 3:15 p.m. So what I'll do now is I will, there's still a few minutes left for the polling questions. We really appreciate your feedback on the polls. We will leave the virtual meeting space open an additional 10 minutes or so, and I will enter a couple of links for you all so you can, kind of check it out after the fact, and certainly I'll follow up via email. So thanks to our speakers this afternoon, to Otmar, Diane, and Jenny, and thanks to all of you for taking time out of your day or your morning or your evening for participating. We really appreciate all of you. Thanks so much for the feedback. All right, everybody. With that, we'll log off from the audio component, and I'll leave the virtual meeting space open for a few minutes. Thanks, everybody. All right, goodbye now.